We'll have a look how we output files from Mistika in this tutorial, and all that occurs under the Output tab of the dashboard. There's essentially two reasons why we'd ever want to render files in Mistika. One is if we've run out of real-time performance, i.e. we're using effects that don't run in real time, or maybe a combination of effects that end up not running in real time, in which case we can then make an intermediate render so that we can play our work at normal speed. The other reason is to export files for other systems or to send to the client or any other external use, because it's all very well having real-time effects like these color correctors, but their results are always generated as we play. They're not actually creating anything physical that we can send anywhere. So as usual, the written manual goes through all of these functions in more detail, but let's look at the principal items in the Output tab. So starting from the left-hand side, under the Render tab, which is the principal area, firstly we choose what it is we want to render, whether we're rendering just images, just audio, or both. These items will light up when relevant, so I'll just jump ahead and make them relevant. They essentially say what to do with the audio. As I have it at the moment, Mistika would create a movie file or image sequence, whatever we've chosen, to contain the images, but then separately it would create an audio file, an AIFF file. On the other hand, so long as we've selected an output format that can accommodate sound and pictures in the same file, this would now allow the audio to be in the same file rather than a separate standalone file. Audio with movie, actually these two are very similar. What would happen here is the images would be rendered to a particular location. The audio would go to the default audio location, which depending on how your system is set up might be somewhere very different to where the images end up. For convenience, if you click Audio with Movie, the audio file will be sent to the same location as where the pictures go, so you can collect them all from the same directory. Likewise, the render file, which we've touched on before, which is the little piece of metadata that describes what steps were involved to create a piece of rendered media. Normally those render files, the .rnd files, live inside the project. However, you can also tell Mistika to send a copy of those off to where the final media ends up as well. You might want to do that to keep everything together, particularly if you're spreading a project across multiple Mistika systems. In the next column along, we get to choose what sort of media we're creating. The default will be Mistika. Mistika's internal file type is known as a JS file. It's a highly optimized, uncompressed movie file. And so if you're rendering purely to maintain real-time performance, or you're rendering for some other reason that doesn't require your rendered file to be sent to a different system, then by and large the JS files are the recommended route. And they come in these main flavors, which would be YUV 422, either 8 bits or 10, and RGB 8 bits or 10, and RGB with alpha 8 bits or 16 bits. If you're working with material that's been captured from a YUV source, you may as well stay with YUV 422. On the other hand, for film work or for working from digital cameras, you might prefer to stay with RGB. RGB takes more disk space and therefore more processing power. The next tab along allows us to choose movie formats instead. So there's a basic set of movie formats, including files that are compatible with Avid. This one's an uncompressed movie format. This one's a preset MPEG-4, for example. You'll notice that you don't have access to fine controls, for example, bitrate or codecs. It's generally considered that the best route is to create a single file of a mastering quality and then use external software to convert to exactly what you need, just for the reason that it's not that efficient to tie up a Mistika system to create low-resolution movie files. In fact, your system almost certainly comes with a very good and very fast converter that could take one of these formats and create practically anything with it. If you go to your programs list, audio and video, and media editing, it's WinFF. And basically you can add in a list of files in here and convert to all manner of presets. But that's external to Mistika. Under images, I can choose any of these image sequences for exporting. So these would include DPX frames of different bit depths, J2Ks. This JFIF here is a regular JPEG if you were looking for it. You can also disable the full res image as well. So you'll notice that there's a full res image here and a proxy res image here. The reason is that Mistika is able to work effectively running a full res image and a lower resolution proxy for speed. Now in most instances you'll never really need the proxy. So the default position is when you're rendering, proxy image is on none, as in it's not going to do it. And in fact when you play images on the timeline, even if you set your monitor to look at the proxy image, then Mistika will generate the proxy image on the fly anyway. But you can also force it here to make user-definable lower resolutions of renders as you go. They are designed really just to improve your playback speeds internally, to give you preview files, as opposed to generating lower res material for your clients. You'll notice also there's a target folder. This relates to path building that we'll look at in another tutorial. But essentially it means that we can create predefined paths where our renders will go to. And then those predefined paths generate a drop-down list here. Likewise, there's a path for audio files. The resolution at which we render is by default the system resolution. So in this case it's saying 1920 by 1080. If I switch this on and change the settings, I can change exactly what the output render will be. So I can adjust the scale and the offset and crops and so on, and use the usual fit X and fix Y to get the right framing. It's only active when this is on, otherwise the render resolution will be as per the system. And it doesn't make much sense putting in resolutions higher than your system resolution, because all processing will occur at the system resolution and then basically be bumped up in here. In this section we can choose how we're processing our frames, so progressive or interlaced. If we have interlaced material going through an effect that affects the line structure of that material, then we need to render in interlaced. If not, if we're on progressive, then we're likely to see some artifacts, just because the different lines in an interlaced frame relate to a different time frame. We can insert a 3:2 pull down for going between 24 frames a second and 2997. We can also remove pull down if those fields have been inserted into 24 frame material. Have a look at the manual for the best use of this function. Also we can tell Mistika to render only the even frames or only the odd frames. This is particularly useful in high frame rate work, where for example you might be working at say 48 frames per second but want to export something at 24 frames a second as a preview file or editing file. The render segments mode specifies how Mistika will handle different input clips to a render. For example, if I were to select this area using the edit marks, Mistika would now render everything from the in point to the out point. And if segments mode is as one segment, it would create a single piece of media that accommodated all of these. So in other words, since I'm on movie MPEG 4, it would create a movie file for me that has 3 clips inside it. Alternatively, if I put it onto split to segments, it would create this as one movie file, then this as a second movie file, and this as a third movie file. It'll give each of those movies a suffix of a number, so movie file 0, movie file 1, movie file 2, unless we didn't want it to start on 0, in which case we can change it here. If we're rendering from 3D stereoscopic sources, we can choose what exactly we want to render. So at the moment, no stereo, or I could just render the left or the right eye. I could create a dual YUV stream, which is the identical format to how an HD Cam SR stores 3D material. Anaglyph, black and white anaglyph, interlaced side by side, top and bottom. So for example, an MPEG-4 side by side creates a file that many domestic 3D TVs will happily play from a USB stick. We then get to name our render. If we enable username, then whatever we render will be simply called whatever we type in here. Alternatively, we can give a prefix of a name, and then each time we render, this number will auto count for us. So if we're rendering lots of things, particularly if we're not too worried about what they're called because they're just going to sit on the timeline as renders, then this means that we don't have to worry about entering a unique name each time. We can burn in some information into our renders, and again look this one up in the manual for the full instructions of how to set up. There's an XML file in the background that specifies what information goes where, but in essence you can choose, for example, I might want the clip information and the timecode for the first 5 frames of my render, and thereafter I only want the timecode in for the rest of the frames. So this is to help with dailies workflows. When I create media, I can choose where it might get the tape name from, in which case it could be the timeline name, which is the name that I've saved my environment as. It could be the render name, which is this, or it could grab the tape name from the first piece of media it finds in the render stack, in which case there's a choice of where it might find that information, from the header of the original file or from the clip definition. Likewise, I can choose where my resulting media might get its timecode from, whether it's from the source clip of one of its timecode streams, or whether it's from the timeline itself. I can use this to maintain transparency, so as I create renders from a given camera file, I can ensure that all those renders always have the same original timecode, so I can easily trace back. Or alternatively, I can just use a timeline timecode. This last function filters where it will find the information from for these items. On Use All clips, it'll simply look for the first piece of media, i.e. the media closest to the top of the stack, that is able to supply timecode and tape ID. Alternatively, it can be told to ignore JS clips. There are certain scenarios where you might use this. For example, let's say you've got some stereoscopic high-resolution camera files that don't play in real time. So you've rendered them as JS clips just to give you your real-time performance, just so you can see what you're doing. And perhaps you've down-resed them to HD just to work, or 2K, whatever. By using this filter setting, you can get Mistika to ignore those JS files that you've rendered as a preview. And to the last column, do render. If I were to press foreground, whatever is selected to be rendered gets rendered now and with all of the processing power available. How I select what needs to be rendered is straightforward. Either I use the edit marks like this, and Mistika is told to render everything in between, or I can select one single item and Mistika will render that. So in the case of an effect stack like this, we would just select the top item. If we do this, we're actually being vague about what we're asking to render. We're basically saying we want to render all of this, but actually we want to render just that, which obviously is conflicting. So if that situation arises, Mistika will simply ask you to be a bit more specific. And I can get it to render the edit marks, in which case it will deselect this and render everything. or it can remove the edit marks and render just that. I can also render in the background, which essentially sets off the render as a background process, leaving me enough power to still work with the Mistika. So as it renders, it just gives me a little progress bar in the top corner that doesn't get in the way. Write script only is to create just the little .rnd metadata file. And we saw the use of that in the more advanced autoconforming tutorial. Those render files can also be sent off to a render farm at a later date, or distributed to other Mistikas. We can remake the proxy files if we're using them. We can also write a color decision list, and again the manual gives full details about how that's implemented. Once the render is complete, we can ask Mistika to run a user-defined script. There are a couple of examples already in there. For example, this one will send an email to a predefined address once the render is complete. Again, look in the manual for how to implement scripts that you might write. The queue is to do with running a render farm, in which case it works in tandem with the write script only. At the moment, with queue set to none, write script only would just drop the .rnd file into our project for us to manually use later. On the other hand, I could drop it into one of the render queues. Now, although the render farm is designed to work with multiple systems, there's actually still a use even on a standalone Mistika, because you can effectively create a list of renders for Mistika to work through. In order to see this, you'll need to enable your render farm and batch renderer in mconfig. So if you don't see these options, your batch renderer is not running at the moment. Again, check that one out in the manual. You can set different priorities to the queues. So there's a high priority and low priority at the moment on this system, meaning that any render files that are sent to the low priority queue will not be dealt with until everything in the high priority queue has been done first. Finally, there's a flush Mistika image cache. You should rarely need to do this, but if you ever end up in a situation where you feel a clip has changed but it's not being reflected on the timeline, then give this a push, just in case Mistika's cached the image. When we render, Mistika will add a piece of media to our timeline. So for example, if I'm going to render this, I can render it as a YUV file, I don't need audio. So we can see that Mistika has simply added a rendered piece of media on top of this stack. Now, strictly speaking, you don't need this stack anymore, you could delete it. Personally, what I tend to do is just group and drop, because then I know that if ever I want to change this shot, everything that I want for it is actually in a group underneath. Of course, likewise, if I had deleted it, but I still wanted to find all that metadata, it's in the media browser, as we've seen in a couple of demos before, because the render has created a folder in the render name. The green clip is simply a reference to this media, whereas the purple clip is the render file. So this can be placed back on the timeline, and that contains all the information of how that clip was made. Also, on the Output tab, in these sub-tabs, I can export an EDL from Mistika. In order to do that, we need to just make sure that items that have no meaning in an EDL, for example, any effect, are hidden. So to make an EDL of this sequence, again, I just put up some edit marks. I can give my EDL a name, choose the format of the EDL, choose what I want in EDL and whether I'm using from statements or not, and then generate the EDL. The EDL then is stored under this name in the output folder of your project. DCP and Totem are more specific items worth looking into in the manual. DCP will only appear if you have that module on your system. So that's for creating digital cinema packages directly from your timeline. And Totem is about clustered management, to manage processing power spread across multiple computers.